Many assume that humanity has stockpiled enough weapons to physically end the world. We hear the term overkill used as a shorthand for the idea that we could easily wipe ourselves out several times over. Humanity currently maintains a global stockpile of exactly 15,000 nuclear weapons, locked away in silos and submarines across a handful of nations. To see this maximum dispersal attack, consider the world's urban centers. There are roughly 4,500 cities with at least 100,000 inhabitants. If we use 3 nuclear bombs to flatten each one, we would destroy every major population center on Earth, killing 3 billion people, roughly half of humanity, in an instant. Even after that systematic destruction, 1,500 nuclear warheads would remain in the stockpile. Such an attack would end modern civilization. However, with millions of people surviving in rural or remote areas, this scenario falls short of a true biological extinction event. To find the absolute limit of our destructive power, we have to move past a dispersed war scenario. Instead, we need a single, localized planetary stress test. We'll take all 15,000 warheads, stack them into one massive pile in the middle of the Amazon rainforest, and detonate them all at once. A typical U.S. warhead carries the power of 200,000 tons of TNT. This brings our single pile to a combined yield of 3 billion tons of high explosives. 3 billion tons of TNT occupies a massive physical volume. It is enough material to rebuild every building and skyscraper on the island of Manhattan using only blocks of explosives. This setup creates an artificial geological event, a direct test of whether human engineering can rival nature's most violent disasters. At the moment of detonation, a fireball 50 kilometers across vaporizes everything in its path. A massive shockwave ripples outward, flattening 3,000 square kilometers of dense jungle in seconds. This blast releases roughly 15 times the energy of the 1883 Krakatoa volcanic eruption, one of the deadliest natural disasters in recorded history. The atmospheric impact is immediate. A pressure wave circles the globe dozens of times over the following weeks, while millions of tons of incinerated material are injected directly into the stratosphere. Worldwide background radiation doubles, likely causing a spike in global cancer rates. Meanwhile, ash lingering at the edge of space blocks enough sunlight to drop global temperatures by a few degrees for several years. Yet, despite the incineration of the Amazon, human life on other continents carries on. Even with every weapon we possess, our current maximum arsenal fails the extinction test. Achieving true extinction requires a larger scale. Humanity would need to mine every bit of uranium estimated to exist in the Earth's crust, roughly 35 million tons, to build the largest weapon possible. This results in a solid cube of warheads 3 kilometers high, possessing the explosive yield of 10 billion Hiroshima blasts. This chart compares that energy to history. While our current arsenal is a tiny sliver, the 3-kilometer uranium cube matches the energy of the asteroid impact that ended the age of the dinosaurs. The impact vaporizes whole mountain ranges and gouges a crater 100 kilometers wide. The Earth's crust rings like a bell, struck by global earthquakes stronger than any in our recorded history. Thousands of tons of material are catapulted into space, raining back down as burning debris that ignites firestorms across every continent. The resulting smoke and ash cast a permanent shield into the sky, dropping global temperatures to near freezing. This decades-long global winter serves as the true kill mechanism. As a complete lack of sunlight collapses the global food chain, the remaining human population starves, resulting in total extinction. In the immediate aftermath, our orbital infrastructure is erased. The spray of ejected rocks into the vacuum of space easily destroys the International Space Station. Survivors in deep-sea submarines or bunkers might endure for years, but they will eventually emerge into a frozen, radioactive wasteland with no way to replenish their food supplies. However, the Earth itself remains entirely indifferent. Within a few million years, the biosphere heals, the climate stabilizes, and life thrives once again, burying the scars of the explosion. If a new intelligent species eventually studies the planet's geology, they will find a bizarre, razor-thin layer of rock. It will be uniquely enriched in radioactive elements, rare earth metals, and the synthetic plastics used by humans. Our ultimate destructive effort cannot actually destroy the planet. It can only guarantee our own erasure from it.